everything you think you know about AI is probably wrong. And you need to understand what it's actually doing to be able to have a chance to use this tool instead of letting the tool use you. So, I'm going to go through all of the common language around AI, and I decided that I would let AI help me on that process. So, I have Cloud Code open, and I'm asking it to give me a list of the most common technical terms around AI. And let's see what it comes up with. What are the common ways that people discuss AI, and what does it mean at a technical level? No idea what this is going to do, but I think it'll be a useful way to walk through more than just my usage of the language. But I'll start off with talking about artificial intelligence. When people discuss artificial intelligence, both of those words are a lie. First of all, it's not artificial. This thing is not a clearly developed programmatic script that follows a sequence of chains, which is often what we think of when we think about artificial. It's grown. You take this layered network structure that's modeled after neural nets off of organic systems. You put it into a machine, and then you feed it, and it grows and it changes, and you keep feeding it data, and it's very, very not artificial the way it grows. We don't understand how it works. We don't understand why the weights it comes up with are the weights it is. Computer scientists that are the experts and the godfathers of AI are terrified of it because they don't understand how it's doing the things it's doing, or why, and what makes it go in terms of capability from previous models to current models. And if that happens again, what does that mean for society? So it's not very artificial. The second one is intelligent. One of the things that I always hear when people talk about AI is AI, I had a conversation with AI, or it thought through this process, or it did these sequence of events, and it's not intelligent. It's not thinking. It's just creating output based off of input. It doesn't have a chain of thought process. It doesn't go through and think. It just creates a series of predictive tokens, which are then processed into language. Cool. We'll have some terms up here. So it's neither artificial, it's neither intelligent. And if you actually think about the underlying architecture behind an AI, if you understand statistics or linear probabilities or basic functions in Excel, if you add a linear forecast, right? You have a series of data points and you create a linear estimate of those data points. That's AI, but just scaled up to a few million magnitudes larger than a normal regression that you would see. But at the end of the line, it's simply just a regression model with weights and a bunch of variables that we feed it. And we feed it input data. It runs it through the regression or the weights and outputs a forecast or a predicted value for the next token. And then it uses that token in the next prediction and in the next prediction. So it creates this tokenized feedback based off of all the previous tokens that you've fed it, and based off of that organic structure that we fed it all that data to try to create those predictive cycles. All right, let's see if we can go and find these files. Let's start with artificial intelligence. Commonly used any software that seems smart. I like that it says it seems smart because they often do look very smart. Artificial intelligence is a huge, broad category of topics. It ranges all the way from deep learning to chatbots to predictive text on your phone to video processing. It is a wide field. But now we talk about AI mostly as LLMs, large language models, which are the ones that are designed to predict language. So that's one big gap, is understanding that there's a lot of other types of AI that we've been using for 20 years and has had a huge impact, like machine learning for robotics or forecasting or predictive analytics. Like there's a lot of ways that we've been using AI for a long time. This is just the first time we've taken human language and got it to a usable state in AI where it can actually approximate human language in a useful way. Yeah, these are kind of just different types of AIs. So we'll keep going through it all, because I want to talk about the language around LLMs. So let's go to prompts and prompt engineering. So prompt engineering is basically the idea that what we type into AI matters. And that's very true in that, a little bit lower. It's very true in that what we type does matter a lot because we are creating the data that AI is going to forecast from. And so we need to give it good data so that it can forecast well. But the interesting thing to me about the way that people talk about prompt engineering is that it's very much not engineering in the sense that it's not as formulaic as we'd like it to be. A lot of times it's more of a social engineering problem. So it's more of manipulating the context around the prediction forecast to be able to get it to create content that we want. So for example, when I try to get AI to do something specific, one of the things that I often try to do is I try to kick it in its brain away from a specific area to another area where my request is more likely to be fulfilled. A lot of prompt engineering comes down to those basic principles. For example, chain of thought reasoning, which is basically the idea that if I say, hey, make sure you do this and then that and then this, and we give it a sequence of steps to follow for reasoning, it doesn't follow those steps, but we think it does. What it's actually doing is it's taking its brain and saying, look towards the section of your brain where logical data has been stored, because that's the type of data that I want. So my forecast, the data I give to the forecasting tool, includes logical structure, which means when it outputs responses, it will output it as a logical structure. And that helps the AI be better because we're pointing its brain towards smarter content, the areas of its brain that have processed smarter content. If I instead want to get dumber content, I could probably use language that's typical to like Reddit or like old school elite speak or bro speak. And I could try to get it to go to dumber parts of its brain if I wanted to simulate that. And maybe you do because you want to look like a community that has that specific characteristics in the AI text that you're generating. It's not actually doing those things. It's not part of those communities. It's just reflecting the behavior. It's forecasting that behavior inside of its mind or inside of its regression output that's reflective of the input data that you give it in the forecast. I lost it. I accidentally minimized it. Okay, sorry. Yeah, we've covered most of that. Parameters and weights. A lot of people don't really understand that these are just simply weights that let the model estimate the forecast, right? So it's the number of parameters in the regression that dictates exactly what the output is going to be. If you've done anything with regressions, you know that more weights isn't always better because sometimes they have covariance and inflation, and you have to like manage the number of weights versus the number of terms that you include in the regression. Because AI has such a huge data set to be trained on, it's less sensitive to that than if I add a few. So the more weights tends to be generally better, but not always. Tokens, I think that's used generally correctly. Hallucinations is really interesting because the way people talk about it is, oh, AI had a hallucination. It made something up. And I think it's kind of interesting because every AI output is a hallucination. It doesn't sometimes make up things. It doesn't sometimes lie. Every single time it outputs content, it's making it up. It's called a generative model because we've trained this thing to be a storyteller. And it tells stories. Sometimes those stories are similar to real world events. Sometimes they sound true. Sometimes they could even be true. But every single time it's a hallucination of the AI creating that story, which may or may not be connected to reality. A lot of the tooling architecture around AI is to try to take and make sure that the AI outputs are filtered based off of how far away their hallucinations are from reality. But every single time AI outputs content, it's a hallucination. Fine tuning is probably a technical term that we don't really need to be able to get into because we don't have control over that layer. But it's basically when you take a model and you feed it all this data, after you fed it all that data, you want it to do something different, right? You don't want it to just take data and output data unless we can structure it in a usable format. So after you've trained a model and you fed it all this data, then you try to put it in a useful format. You try to cage it, give it a nice area that it should behave on. A lot of that comes down to teaching it to be a chatbot, for example, or teaching it to be a programmer, or teaching it to respond in an interface that's very useful. Yeah, we'll skip some of this about the technical level because I think these are really important for the AI researchers to understand it. But a lot of this comes down to what were the leaps in technology that AI was able to accomplish over the last decades to be able to get it to where it is right now. Transformers was a big part of what made the modern ChatGPT AIs possible, right? It allowed it to overcome technical limitations of the past that it needed to be able to scale, right? Part of that was the attention mechanism that was raised up, which allowed the AI to focus information, to capture, instead of just looking at everything as a series of lines, it allowed it to connect between different concepts in a less linear way. And that allowed it to be a lot more flexible and connect more of the dots between it. One of the things I think that we often don't think about when AI tells us a series of texts is how much of that is generated to connect the answer that it wants to give back to the user's query. And it wants to connect those ideas because, I think in large part because of this attention mechanism. And when it does that, it feels like a rational thought process. It feels like a sequence of events, but it's really just taking me through this chain of events to the output that it wants. And I think this is one of the reasons that the phrasing that AI we see often feels very artificial, because it has these transitional phrases that take me from one topic to another. It's not just that AI does this. It's that it does that because that phrase, it's not this, it's that, is a really good syntactic phrase to take me from topic A to topic B in a sequence in a flow, right? So it's connecting from my prompt to the answer it wants to give and drawing that line in between it. And I think that's a really big part of why we see so much of that language in ChatGPT content that's online now. It's not just that the AI uses that language, it's that the AI shifts the conversation with that mechanism, and it has to do that because it's trying to get to the answers in its brain that it wants to give you. Context window is really interesting. So the context window is basically how much information you're feeding to the AI every time you send it a request to generate content. People often talk about it's like how much the AI can remember, or how much information we're having in this conversation. How long can the AI remember this conversation? But honestly, there's no such thing as an AI that has context. All of the AIs exist in a space where you give them a series of data and they give you an output, and then you take that output. The next time you have a message, so if you're just on ChatGPT and you send a message, you say hi, and it says hi back or whatever. The next time you send that message, it's a new AI. It's not the same one. You take your message and you add all the history to it, and you send that new message to the AI and says, hey, we already said these two different things. Now we're here. And I can show you a really easy way to see that example, that the AI isn't actually part of the conversation. Let me see if I can pull that up real quick. Maybe I'll show that later because I think it's really good. So the context window is really interesting to me because every time I talk to an AI or get a response from an AI, it's taking all of the information I give it every time. Usually that means I'm giving all of the transcript and all of the previous interactions with AI up to the AI model again. And let me give you a really simple analogy. So this is like if I went on a date every week, and every Friday I go out for a coffee date and I meet a new person. I say, hey, I'd like to get to know you. Let's talk about some of the stuff we like. I talk about AI. She leaves because she doesn't want to talk about AI. Next week, I meet a new person, right? And what do I do is I bring the transcript from the previous conversation with me and I hand it over to her and I say, hey, read this. This is what we talked about last week. And then I begin the conversation. And the new person has all of the previous history of the conversation. She also leaves because I gave her the transcript from the previous time I met with someone. I go home, I print up the new transcript from both of those two different chats, and I go to the coffee shop next week and I say, hey, nice to meet you again. Since we've already talked twice, here's the transcript from when we had those conversations. What do you like to do? And she says, not this, and leaves. And I keep trying to imagine that this is the same person, but it's not. It's a different one every time. I'm just feeding them the transcript. I'm feeding the AI the transcript of the previous conversations. That's the context. And it can only have so much context at once. So the bigger the context that we share, that's the more information of the previous conversation or the things that we want it to look at and manage at once. Context becomes unstable as we go from very low to very high amounts of context. And you can measure it. You can go and see how much is the instability as we go from low context to 100. If you say I have 1 million context window, that might work up until like maybe 800,000 or 500,000. And then it starts to degrade. The whole system starts to collapse because it's more information than the AI can actually handle in its forecasting model. Yeah. I hope that kind of makes sense, because every time I talk to an AI, it's a brand new context. I'm just giving it lots of that context with me. There's a few tricks in that to make it a little bit more manageable, which is mostly caching, which is storing a lot of the previous context from the previous chats remotely so that it is more accessible, so that I only send up the changes, the new transcript every time. So basically, like at the coffee shop, I keep all the transcripts on the table and from the previous conversation. And when I show up, all I need to do is add the new transcript during the date. And I add all the different text to the top of that pile, and then I leave the context there. I go home. Next week, I come back, and it's still there. And so that context is cached. It stays there on the remote system. Saves a lot of money. Context windows being collapsed usually is there's too much information. We can't have it. Let's squish it all. Write a summary document of all the information in AI. Put all the information into a very short form summary. Maybe it references some of the previous content. Like if you need to go look, you can go see the conversation history here. But for now, really, like this is the summary of the conversation. Which, again, if I go back to the coffee shop example, what that basically means is on the table, I have a summary. I have been dumped every time I've tried this with a date because this is a terrible way to have a social relationship, because it's not a meaningful connection, because every single interaction is a different person. That'd be my summary of that context. Yeah. Artificial general intelligence is the idea that AI is going to do an order of magnitude level of skill growth. We are so far away from that, I don't even think it's worth talking about. We need to have exponential leaps in capability to be able to accomplish that. I don't know if you guys know this, but I have another video on AI systems where I talk about how dumb each AI is. And AI is basically run by chickens. And that's the level of intellect that AI has. We just have really good tools to keep those chickens going where we want to go. So if you haven't seen that analogy, it's worth going back and watching that video. Alignment. Okay. Alignment is trying to get the AI to do the things we want it to do. And again, that's kind of like what I was saying, is like we have a bunch of dumb chickens that are trying to get out. and we want to make sure the chickens are going the direction we want to go. And my previous video covers that probably in more depth, so that's probably worth it. Okay, this one's a really big one I want to talk about. AI agents. We talk about AI agents as these AIs that have specialties that aren't a person or AI doing this thing. And we talk about them like the same thing doing a pattern of behavior. Like, oh, I have an AI agent that's going to run a conversation with me. It's going to do this task where it acts as my sales representative or my email reader or something like that. And it's similar to the other issue with the context is every interaction I have with that agent is its own independent API call. It's its own independent AI call to predict and forecast the next piece of information. But it's doing it like in a lot of series, in a lot of sequences. So we act like it's this independent group, but under the hood, it's all basically the same API call to an AI. We're just changing the instructions that we give it. We're saying, hey, dress up in this outfit every time we talk. And when we tell it to do that, it dresses up in that outfit. And it will do that because every time we send a message to it, we ask it to dress up in this outfit. It's the exact same way, like the tooling itself isn't any different. What we're doing is we're creating a really good specific set of boundary conditions to behave in this specific way. We're giving it really good input data to make it give us really good output data. Okay. When it's like a multi-step task using tools to do all these different things, what it's basically doing is it's just calling the API over and over and over again with the context window. So it's basically saying, hey, all of you chickens that are running my AI system, please go and accomplish this task. And we'll send a chicken out, and the chicken will come back and say, I couldn't figure out where that link was. And we'll send the next chicken out to try to accomplish that task. And it'll just go back in sequence where we try to get the chickens to do what we want them to do. And that's an agent-based system. If we have good instructions for the chickens or good dogs keeping the chickens in line, then we have a really good chance that the chickens do what we want them to do. Okay, a RAG, Retrieval Augmented Generation, is basically, it's very similar to agent-based systems because we're basically taking and we're bundling information we want the AI to process. It's documents that give AI instructions, like do this thing, act like this. What it's doing is it's creating good boundary conditions that the AI has a harder time leaving. But it's very similar to an AI. So an agentic AI is basically the same thing as a RAG in a lot of ways because we're just passing that information up every time. Sometimes those RAGs are selective. Like we can say, use this RAG when you're doing this thing, right? When you're generating a Word file, go to this reference document. But we also have agents that also are very similar. So like when you do this as an agent, also do that. Oh, this is pretty interesting. I haven't looked into embedding much, but basically like taking and making the RAGs that we take from plain text and making them much closer to the way that the AI processes information. It's basically taking and distilling the data we have from plain language to the mathematical representation or the vector of that information. So we give it more dimensionality than dog. So that's cool. I'll look into that and see how hard that is to do and whether or not it's useful. I'm not going to talk too much about the AI image generators or the diffusion models because they just operate on an entirely different system of architecture that isn't the text-based. Most of the AI LLMs are fully text-based. You send them text, they give you text. That's it. There's no other depth to that interaction. It's just text. They often call other tools, like they might call a calculator, or they might call Python script to run a specific tool, or they might call an image generator, but the LLMs that we interact with often are just text generators. Okay, I think we've covered most of them. All right, I'm going to talk about, yeah, I think that's good. So I covered quite a lot of the main topics. Hopefully those different framings of it helped you understand all of the terminology. One of the biggest things I think is worth knowing is that every time someone discusses an AI doing a thing, it's usually 100 AIs doing a thing. It's very rarely one AI making a series of choices. Usually it's one AI making a very small text-based decision, and then us interpreting that decision and creating different information from that, and then passing that information back up to a new AI to say, hey, here's the context of what the last AI did, which was you, and here's what I say. Now what do you do? And the new AI gives us a new decision. So when people or researchers or scientists talk about AI went through and played a game of and ended up doing nuclear war decisions, it's very scary. But typically what that is, it's a series of individual AIs along the way that made a series of choices that all ultimately led towards that specific output. It's never one AI that makes that same decision in a loop. It's basically an AI that keeps getting additional context fed into it in a constrained format to try to create output that isn't just AI quickly deteriorating into madness, which it does. Cool. Yeah. So everything you know about AI is worth checking to make sure you know it well. Because if you're going to use this tool, you need to understand how to manage the chaos. It's basically trying to take and leverage the power of one of the stupidest things that we've invented, dumb as a chicken, and turn it into a useful tool. The better boundary conditions, the better constraints, the better organizational structure we give it, the more likely those chickens don't escape. If we fail to do that, the more likely those chickens escape. And we have to understand the architecture to be able to make sure the chickens go where we want them to go, because every time we AI generate something, it's a different chicken. And it will read those instructions differently. It'll read the context differently. It'll read the RAG differently. And it won't remember anything of the last chickens except for what those chickens are shared, what the information from those previous chickens is shared. They're just all brand new. And it's pretty important to be able to manage that, because it gets very complicated very quickly. And if we have the chickens going in the wrong direction, it's very hard to correct the path and get them back on. So understanding the technology behind it, if you're going to use this tool, is worth it. And that's it. I hope that was useful.